Hello boys and girls, my name is Watson Chanaka, the computer teacher. Okay, we're going to continue with the computer studies. Last lesson we talked about the history of the computers. Today we're going to be talking about the types of computers. So looking at the evolution of computers, we talked about the first generation where they used the valves, which was the computer, which was the ENIAC computer. Then we moved on to the second generation where they were using the transistors, the third generation where they created the integrated circuit, and the fourth generation where they created the processor or the integrated circuit at large scale. Then we finally got the fifth generation, which was the artificial intelligence. So we said the artificial intelligence, it means that nobody knows what was coming and nobody knows what is coming. The scientists still have the objective of reducing the size of the computer. Now, they managed to do that. They managed to reduce the sizes of the computers. Then also they started to create a lot of computers, which also created another confusion in the market. How to distinguish between the computers. So today's topic, we are going to look at the types of computers. Okay, before we start with the types of computers, we're going to talk about the definition of the computer. A computer is an electronic device which is used for inputting data, processing, and give out information. It also stores data for future use. So if you check, we've got a lot of definitions which we can bring up on the types of computers, on the definition of a computer. But the most important of all, so I'm looking for a pen here so that I can highlight what I want. We have to work with the keywords, which is very, very important. In your definition, you should talk about any electronic device or an electronic machine, which means that it works with digital data, which is 0 or 1. You should also talk about input devices, anything which is to do with the input data. Like we're talking about the keyboard, the mouse, the microphone. I'm talking through a microphone, so it means that it's an input device. And we should also talk about the processing, where whatever information is going to be put inside the computer is going to be processed. Then we should also talk about the output. Through the monitor, you can see what is being processed. Through a printer, you can see what is being processed. Through speakers, you can hear what has been processed by the computer. So these are the key terms we need. Also storage for future use. So it means that whatever we're going to be processing there, 1 + 1 has been processed inside the computer. We now have a result. What are we going to do with the result? Throw it away. Then tomorrow we start again calculating? No. We have to save that information for further use. We can develop, we can reuse that result to make other things. Okay, so that's the definition of a computer. Then we also have the characteristics of a computer. What are the characteristics of a computer? What should it have? It responds to specific set of instructions in a well-defined manner. In a well-defined manner. So it means that when you give instructions, when you click, the device which is used, we talked about input devices here. An input device which gives instructions to a computer is a mouse. When you double click, for example, I want to open a document, you double click. It means you are giving instructions to the computer. When you double click, it means that the computer knows that you want to open. It's going to execute. It can execute pre-recorded list of instructions using what we call a program. So it means that a computer program is a set of instructions which execute whatever task you want. They are step-by-step instructions which are followed by the computer to execute a task. So this is what we call a program. That's why when you double click, there is already a program which responds to any double click. It means you want to open something. You want to select something. When you right click, it's going to give you a menu. That means it's an instruction which has been recorded inside the computer. It can quickly store and retrieve large amounts of data. So it means after processing that data, you gave it instructions to store some information. Okay, it's going to store that information. Retrieve is a technical word we use to take what have been stored. I want to see what I recorded yesterday. I want to see what I solved yesterday. I want to see what I calculated yesterday. So it means I'm going to retrieve from the storage device to the monitor so that I can reuse or I can continue working with the same data. So it can retrieve large amounts of data at the same time. It can also perform complex and repetitive procedures quickly, precisely, and reliably. Computers, they don't think more than people. We always say that. I've heard people, a lot of people saying computers, they think more than humans. That is very, very wrong. Humans think more than a computer. Who designed a program, a computer? It's a human being. Who designs a program? It's a human being. The only difference is that a computer can execute instructions without tiring. It can repeat 20 times the same thing, 300 times the same thing, which we cannot do. That's only the advantage. But all the thinking, it has been done here by a human. All the instructions, we created the instructions so that it can execute it through a program. So it's only, a computer only has an advantage of processing whatever instructions we give it very, very fast. And it doesn't tire and is very reliable. Only that. But in terms of intelligence, intelligence is within us. We take our intelligence into what? Into a program. Then the computer is going to execute that intelligence. So it's not the computer's intelligence, but it's the computer's reliability, which can help to achieve our goals. So these are the basics of a computer, the characteristics of a computer, what you should have. Let's move on to the next slide. We've got all general purpose computers that require the following. It's a subheading. When you talk about general computers, I'll give you an example of a general hospital. At a general hospital, it means they treat everything. Everything. The eyes, the teeth, the whole body, bones and all that. Everything they treat there. It's a general place. Computers, they also have general services. And it also has specific services, just like at the hospital. There are some certain areas where they only treat with the eyes. They treat the dental department. Also computers. We have computers which are specialized, for example, for storage. Some, they are specialized for databases. Some, they are specialized for networking. So those are specializations. We'll talk about that later. But looking at the general purpose computer, it has all of these capabilities. One, let's talk about the hardware components. Hardware, these are the physical components of a computer system. Anything you can touch on a computer is called hardware. So all computers, they've got a central processing unit, which is the brain of the computer. Some, they call it a heart of a computer, but it's not a heart because a heart doesn't think. It's the brain of the computer which has to think and execute those instructions which are predefined by the user. So the brain of the computer is actually the processor. We'll talk about it later. We have a chapter which we're going to be focusing more on the central processing unit. We're going to get inside the processing unit and see whatever is stored inside there. So it's very fast in processing. It does all the thinking. Then we also have the memory. Memory, it stores instructions, but it stores them what? Temporarily inside the computer. For example, you're going to type your name on the keyboard. It's going to be displayed on the monitor, but it's not disappearing. What is holding that text there? For example, I'm going to write here. This is not saved. Whatever I wrote here, it's not saved. What is saved is the black part and the blue part, but this red one is not saved. But what is holding it there? It's not disappearing. What is holding it? It is the memory. It holds data temporarily inside the computer. If I switch off this computer, I'm going to lose whatever I'm going to be writing with this red marker here. But this blue and black, I'm going to get it because it's already saved. It's not held temporarily. But whatever is being held now temporarily is this. So that's the function of a memory. It holds data which is going to be processed. It's waiting for processing. If the user decides, okay, I want to save this information, it's going to save it in the what? In the storage device. Then it's no longer being held temporarily, but it's now definitely inside the storage device. So we have a storage device, which is the hard disk. When you switch on the computer, always it's going to upload Windows 7. It's going to upload Windows 8. It's going to upload Windows 10. That is a system. Even your phone is an Android. Switch on the phone, for example, if you're using Samsung, it's going to write Samsung. It means that inside that there's storage. Inside that storage, there is a program which is called Android, for example. There's another program which is called Windows 7, Windows 8, Windows 10. It's going to load on your computer. So this is stored inside a what? A hard disk drive. We also have a flash disk which stores information outside the computer. Now this one I can carry it to anywhere. It's different from the hard disk. Hard disk is internal. It stays inside the computer, whereas a flash disk is an external device. A memory card is an external device. I can carry it to any other device and it's going to work. Then we also have input devices, which are very, very important. Input devices are used to enter data inside the computer. I want to type, I'm going to use a keyboard. I want to give a computer instructions, I'm going to double click to open a document. I'm going to use a mouse. So a mouse is an input device which is used to give instructions to the computer, whereas the keyboard is an input device which is used to enter data inside the computer. So if I ask you the function of a mouse, please don't tell me that it's used for clicking. No, that's wrong. It's used for moving around the screen. No, that's wrong. The main function of a mouse is to give instructions to a computer. When you click, you're giving instructions. Click, you're giving instructions to what? To a computer. So it means that if you click once, the computer knows what you're doing, what you want. If you double click, the computer knows what you want. If you right click, you left click, those are instructions which you're giving to the computer. Then we also have, for example, I'm talking through a microphone here. I'm also taking my voice inside the computer. It's being processed inside the computer there. So it means that a speaker is also an input device. Then we also have output devices. Output devices, we're talking about that. Okay, let me draw something here so that we really understand. We have the system unit here. We have all drawn this. And we have the monitor here, and we have the keyboard here. We also have the mouse here. Okay, the cables, they go to this cables of the monitor, keyboard. Okay, we're here. This is the switch button. So if you write anything on the keyboard here, you're taking that information into the computer. You're going to click here, but when you click, you are actually here, right? But you're giving the instructions where? Here. This is what we call input. This is input now. Then we have what we call output devices. Output device, sorry, I forgot. I'm talking through a microphone here. Okay. There's a cable which goes there. It means my voice is also getting inside the computer. It's input. Then we have output devices. It's going to take information out from the what? From the computer now to what? To the screen. So it means a monitor is an output device. We also have a printer. You draw a printer like this. It's very easy to draw a printer. And computers just draw it like this. This one. Okay, you want to print whatever is here. It's going to go there. We are taking out. I'm talking through the microphone, but it's going to be out through the what? Through the speakers. So these are output devices. So it's very important to have input. Okay, we have information inside the computer. You have to take it out through the output devices. So these are the basics of any general purpose computer. It has a processor for processing whatever data is there in the instructions. We have the memory which holds the instructions temporarily inside the computer. We have storage, which is going to store whatever information we have inside the computer, and we have input devices, which are going to introduce data inside the computer. Output devices is going to show us what is being processed by the computer. So these are the general purpose devices. Okay, after the 1981, after the IBM PC, which was launched in 1981 by IBM, which is the International Business Machine, there were a lot of computers which just popped up in the market. Then it was a great problem now, how to distinguish the computers. They all looked alike. Some they were a little bit different in terms of size. And literally they were kind of like everything is processing, is doing something great. Looking back in time, every computer was doing great. But then there was a big problem in terms of classification. Companies needed to buy computers for certain purposes. Some bought home computers to do industrial work, and no results were satisfactory. Some bought industrial computers to work at home, and they were just wasting resources. It was perfect, yes, but they were wasting resources, because at home just typing, playing games, watching movies, playing music, just wasting resources. So they decided to classify the computers into categories. Then the first category was a personal computer. A personal computer is a small single user based on a microprocessor. It means these are home computers. The ones we have at home, the ones we have in small offices, the ones we have in schools, or the ones we have in the computer lab there at school. Those are called personal computers. Look at the name personal. It means you do whatever you like. It serves your personal interest. That's why it's called a personal computer. And if you check here, a single user. A single user. It means one, but nowadays they can handle up to 2, 3, 4 people. 4 connections they can work on a computer, as long as it has got a good memory. But the minimum is 2. It can handle 2 people processing at the same time. Then we also have a workstation. A workstation now, this one is used for small businesses, small companies. It works, it's a little bit powerful, single user computer. Workstations like personal computer, but it has more powerful microprocessor. So it means it's more powerful than what? Than a personal computer. And in general, a higher quality monitor. Okay, basically there's some information which is missing here. A workstation can also help to serve as an information system processor. For example, if we're talking about the information system, it means, for example, companies which work with accounting. Okay, they've got an accounting system here, but there's a user here. There's a manager, is working here. There's an accountant, is here. There's the director of the company, it's here. Okay, he does his own thing. He does his own stuff. He also does his own stuff here. But at the end of the day, they all access the accounting system here. So it means it's centralized, but they can also connect to this kind of computer. So if you use a personal computer, it's going to freeze. It doesn't. It's a single user. It may get difficulties in accepting a lot of connections here. But a workstation now, it can help you a lot. It can handle 3, 4, 5, up to 10 users at the same time processing with this powerful processor. Then we also have a mini computer, a multi-user computer capable of supporting up to hundreds of users simultaneously. So it means a mini computer is a central computer like this one here. But on this central computer, we can have 300 people connected here. We're talking about, for example, a supermarket. In a supermarket, if you are at the cashier, let's give an example of ShopRite. How many tellers are there? Maybe 14, 15, 20 there, which are there. But those machines there, they are connected to what? To a central computer here, where they are going to be processing. Each cashier there is connected to what? To the central computer, which is called the mini computer. Mainframe. The same explanation I gave to mini computer, I will explain again later in the next slide there. It's also a central computer, and it's a powerful multi-user computer capable of supporting many hundreds of or thousands of users simultaneously. Here, we're not talking about Facebook. For those who have Facebook, how many people have got Facebook accounts? They're all here. How many have got Twitter accounts? How many are on WhatsApp? So it means those hundreds and thousands of people who are connected to the same computer here, exchanging messages on Facebook, exchanging messages on WhatsApp, they are also working on a mainframe computer. Then we have a supercomputer, an extremely fast computer that can perform hundreds of millions of instructions per second. Listen to this, hundreds of millions of instructions per second. So it means it's a supercomputer, as the name suggests, a super, just extremely fast. Where do they use this supercomputer? It's used in research centers, military bases, meteorology, weather forecasts. They use this kind of a computer. I will explain now deeply now using this diagram. Okay, so this classification we have here is based on what? The processing power. We have the basic ones, which I said these are for home and small office, and usually we call it SOHO. SOHO, it means small office, home office. So it means you can have use it at home as an office computer. You can even small offices. It means those small companies, they can also use this. Like our school, more international. We can also have these computers in our computer lab. These are personal computers. They can help us just achieve whatever we want to achieve. Then we have workstations, which I said they can be used to improve the connection or the speed of the personal computer. Okay, we want to connect to a database here. We can use what we call a workstation. We have got a lot of processing to be done at school or at work. We have to use a workstation. Okay, my main interest, these ones I think I explained them very well behind there. But before I go, in the personal computer we have the Macintosh. Macintosh, these are the Mac computers, which have got an apple, a white apple, like this one. These are called the Mac computers. These are personal computers. I think we'll talk about them later in the chapter. But these ones were the first personal computers, which were very, very small. Then the personal computers, they came up in 1981 with the personal computer. And the personal computer category, we're talking about the HP, we're talking about the Elsa, we're talking about the Dell, we're talking about Lenovo. These all fall under the personal computers. Whereas Macintosh is only one Mac computer, which is from Apple. Okay, on the mini computer now, let's go back to the history of computers. I'll start from the mainframe. Looking at the first generation of computers, those were very, very big computers, which were used to process data centrally, to a centralized processing. So those big computers, with time, they reduced it. They noted that, okay, they improved the capabilities of processing, they improved the capabilities of processing speed. So it means they were connected over the network. This is a client, this one is a client, another client, another client, another client. This one is processing information. They worked in batch. Batch, it means this one processes information on his side, this one processes information, this one processes information again on his station. At the end of the day, they all take their results to the main computer for processing. This was the main computer. Then these guys of the mini computer now, they noted the problems of the mainframe. They improved those problems. One thing they improved, which was very significant, it was the size of the computer. So they reduced the size of the computer to a very small computer, which was very, very small compared to the mainframe, but holding the same what? Capabilities. They even improved the centralizing process. So it means they were now working, for example, 10 or more people working on the same computer at the same time from these stations here. It means that this one is working here, this one is working at the same time, not in batch processing, which was now what we call real-time processing. We'll talk about these types of processing later. So it means everything was being processed here. So when these guys of the mainframe noted that mini computer has reduced the size of the computer, and they also have all our capabilities here, even much better, what did they do? They also reduced the size of what? Their computer to the very same size of the mini computer. They took all the functions of the mini computer and they also have them. So mini computer and mainframe was now difficult to distinguish between them. So what do? They gave them a general name. Okay, let's meet in the middle. Let's give it a general name called a server. Why the name server? These ones which are connected over the network, they are called clients. So it means a client, he is served by a server, or a server serves the what? The client on the network. Yeah, it's going to say, what do you want? Okay, give you what you want. Just like you do in when you go to a restaurant, you've got somebody who's going to be serving you. What do you want? Okay, this one. That person is going to be going to the kitchen, is going to get your order, bring it to you, and all that. So the server, it also takes all the orders from the clients. It's going to take it to the central processing unit we've talked about. It's going to process that information. If the user, for example, requires space for storage, it's going to take that information to the server, to the processor. It's going to tell the processor, user Watson, for example, he wants to store his 10 gig data. Can you give him space? Yes, I've got it. He takes that data and he stores that data. So they created a general name called a server. Nowadays, if you look at the servers, they're now the same. No more mini computer, no more mainframes. But they didn't leave their names. Okay, it's a server, but it still holds the names mainframe. Some of them, they still hold the name mini computer, but now they bring up the servers. So you can see we've got HP servers, we've got Dell servers, we've got a lot of servers which come up with names there in the market. Then we also have the supercomputer. We talked about the supercomputer. So supercomputer, it means it's a very, very fast computer, more sophisticated than this one of a server, of a mainframe. Okay, let me give a general explanation before I go to supercomputer. I'll give you a general, for example, let's give an example of a BIM. Not of a BIM, of BIM, the bank. I'm here in Chimoyo. I want to deposit money to somebody who's in Maputo, so that you just understand how it works with a mainframe or a mini-frame or a server. I deposit money here. I'm going to go into the bank. That person in the bank, his or her computer is connected to what? To a mainframe. It's going to deposit and it's going to leave the details here. This guy I deposit money in Maputo is going to go into the bank or an ATM. ATM machine is also connected to the server. It's going to go to the ATM there. It's going to access his account here. Oh, the money is already there. He's also going to withdraw. So it's a centralized system. It's very good. But if there are too many connections, the system will be very, very slow. If it has got less capabilities, less memory, less storage, less processing power, it's going to be very slow. If you have noted, why do we have a lot of queues in the banks at the end of the month? There are a lot of queues in the banks because the servers which are there, they don't have the capabilities of attending to millions of or thousands of people at the same time. They can do that, but they are very, very slow. You try to swipe a card, it rejects because of congestion. There are too many people who are accessing what? The main computer here, so it becomes slow. But if it has good capabilities, it will attend quickly and everybody will be satisfied. But now what happens with the reality? These machines are very, very expensive. So they buy just the basic machines That's why if you come at the end of the month, try to swipe, you've got a problem, you just in the queue, just take hours to withdraw your money and all that. Then it also has a problem. If anything goes wrong, okay, let me change my color here. Pointer color. Okay, let me change it to black. Okay, if anything goes wrong with the server here, it's down. Something wrong with the computer. It's sick. It means that everybody is going to stop working. Why? Because they are all connected to what? To the main computer here for processing. Even the ATM is going to be down. You try to go into the bank, they'll tell you that no system. There's no system. Why? Because the main computer is what? It's down. So that's a great disadvantage. It's only an advantage when everything is working, but if it goes down, everything also goes down. That is a great problem. Then we have supercomputers. A supercomputer, like the name suggests, it's very, very fast in processing. It can process millions and millions of instructions per second. Okay, this is my idea. I'm a thief. I created some crime. They saw me. They took my photo from a camera, from an invigilating camera. Okay, the police got the photo or the video or the clip. They're going to take that video to a supercomputer. They're going to run my face there. They're going to scan it, looking for matches. And those matches, they're going to be looked into about 3 million people, for example. But it's going to do that within a minute or less. Or within 30 seconds, you're going to bring 20 matches or the same face. Then they're going to ask it to redo another scan. From these 20 faces here, it's going to bring them down to what? To 2 faces. From the 2 faces now, they can now retrieve the names. Okay, what is the guy, what is the description of the guy? Okay, this. What is his name? Maybe they knew my name. Oh, Watson. This is the guy. So within 30 seconds, it's going to scan 3 million people and it's going to bring these faces. What does that? It's the supercomputer. I think we've all seen this in the movies there. It's real. These are supercomputers. Okay, cyclone is coming. Cyclone Idai is coming at 300 kilometers per hour north of Mozambique, passing from the Indian Ocean to inland. Who's doing that? Who's calculating that speed? And who's watching? It's actually the supercomputer. It has got some powerful sensors which can sense and get up the temperature, the speed, and they're going to say maybe the cyclone is going to hit Chimoyo around 7 o'clock, and around 7 o'clock for sure it's already in town. So what does that? Is the supercomputer. It's very fast, very accurate, and very reliable, and very, very expensive. This one, you don't get it in companies, you don't get it in schools, even at home. It's not worth it. It's wasting resources. But you get them in government. We're talking about the meteorological department for weather forecast. They use this one. We're talking about the military. They use these ones. We're talking about the research centers, nuclear weapon. For example, those who work with nuclear weapons, they want to research. They want to research about coronavirus. They use these supercomputers, which are very fast in detecting the results. For example, they are taking people's results, they're going for an analysis there. What does that? It's a supercomputer which is very fast. If they use this personal computer to detect somebody, whether it's coronavirus or not, it may take years. Even the person may die while they're still trying to wait for results. But now, within hours, they can give us the results through a supercomputer. So these are the types of computers which we have on the classification. This was the very explanation I was giving you around these characteristics. We're going further in the next lesson. We're going to start on the personal computers. We're going to further divide these categories here. We're going to get deep inside the personal computers, get deep inside the workstations, get again deep into mini computers. We're going to be talking about the personal computer types. So we're going to start with the personal computer types as we go on. So any questions, please send them to Google Classroom. Send them to my WhatsApp group from 8 a.m. to 8 p.m. I'll be there to respond or you can write your comments on YouTube. That's okay. Or just send an SMS. Thank you for watching. Until the next lesson.